Section 9.4, Inequalities in two variables. Let's try finding the solution for the inequality y is less than x plus 3. So first step is we have to go ahead and graph the related equation. So in this case, the related equation would just mean, for a moment, assume instead of a less than sign, we have an equal sign. So how would we graph this? It's already in slope-intercept form, so we go ahead and plot our y-intercept, which is 3, and then the slope is 1, which tells us to go up 1 and to the right 1. We could draw a few points. You can always go in the opposite direction. Remember, to go in the opposite direction, you do the opposite rule. So instead of going up 1 to the right 1, you go down 1 to the left 1. Now the question is, do we draw a solid line or a dashed or dotted line? And in this case, we do not want the line itself because we don't have an equal sign, so we will draw a dashed dotted line. Now you have two options on figuring out the region that satisfies. We can take a test point. I'll go ahead and do the test point method first. So I'll call that TP. And the most obvious test point here would be the origin. So we can go ahead and try the origin. Remember, this is my x, this is my y. So let's go ahead and substitute that into our inequality. 0 is less than 0 plus 3. 0 is less than 3. This is a true statement. Therefore, because this test point came from this region, every point in this region will satisfy. So we go ahead and shade that region. So this shaded region is our solution. Now, let me show you the method by observation. So when looking at this inequality, the y represents basically all the y values, and this represents, let's do this in a different color, all, or the line itself. Okay, so the line itself, here we have it, the purple line that's dotted. Now we are looking for the area of the line that is, or basically, sorry, let's go towards the y. We are looking for all the y values that are less than the line itself. So let's see where those two intersect. Here are all the y values, our vertical axis, and here is the line. So we basically end up cutting our y values into two pieces. The top half, which would be up here, and then the bottom half, which would be here, right? Two pieces. Now, generally, we would think lower or less than is below. So it seems that these values of y are less than the line itself. And you can always do a quick check by choosing a point, a quick test point. But in general, that's how you can do this by observation. We see that the line cuts the y-axis in two pieces. These are the y values above. These are the y values below. Below implies less than. So the region where the bottom part of the y values is in would be our solution, which would be this green shaded solution. Let's try another example. Now we have a system. So we'll do the same thing. We'll go ahead and graph each one on the same set of axes, and we will go ahead and shade each one. Now we are looking for the overlap. Remember, the solution to a system is a point or a set of points that satisfies all of the equations or inequalities of that system. So in this case, we are looking for all the points that satisfy both inequalities. So let's go ahead and first graph y is greater than or equal to x minus 1. So we put our y-intercept at -1, and the slope is 1. So we go up 1 to the right 1. We can go ahead and draw a few points. Now, do we draw a solid or a dotted line? We draw a solid line because in this case it's greater than or equal to, meaning that the line is also included. Let's go ahead and do the graphing first so that we don't forget. So let's do the observation method. Remember, this is the line itself, which is our line, and the y values, this is the y-axis. We want the part of the y-axis that is greater than the line itself. Well, greater than implies above, so that would be this general region. So let's go ahead and shade this general region up here. Okay, now let's do a different color for the other line. Okay, now we want y is less than negative x plus 3. So 1, 2, 1, 2, 3 on our y-axis. Our slope now is negative 1. So it's negative 1 over 1. So that would mean down 1 to the right 1. We can go ahead and draw a few points. And now we will draw a dotted line because we see that there is no equals. We don't want the line itself. So we can go ahead and draw a dotted line. The proper way to draw lines is always to include arrows. Now let's do our shading. I can go ahead and choose a different color here for the shading. So now we want, here's the line itself, and these are the y values. We want the y values that are less than the line. So here's our line, and this is where it cuts the y-axis into two pieces. The one above here and below here. It's this region here that's considered to be less than. So it would be this general entire region, right? Because now we're shading with respect to the red line. So we want this region here. Okay, so if we look at this, our overlapped region is basically this entire region right here. Okay, so make sure you make it obvious on your homework or on a test or a quiz, which is the solution region. So I'll just go ahead and kind of put this in black. So it's from this dotted line up until this solid line and everything in between. So I kind of put here, this region is our solution. So just be careful with your shading. Okay, let's try one more. So another system, and this time in this system, what we want to do is first find the solution, and then we want to find the vertices of the solution. So let me go ahead and put that here as well. Find vertices. Okay, so y is less than or equal to 2x minus 3. So we'll go ahead and put our y-intercept -3. The slope is 2, which would be 2 over 1. So we'll go up 1 to the right, up 2, sorry, to the right 1, up 2 to the right 1, up 2 to the right 1, and this will be a solid line. Now this one, y is greater than or equal to negative, oh, sorry, let's go ahead and do the shading, I forgot. So here is our line. We want all the y values that are less than or equal to the line. So this is where it cuts the y-axis. Less than would be all this general down here. Okay, so just going to do a little bit right now. We want this region right here. Sometimes if you make it too messy, it's a little hard to see where the overlap region is. So don't scribble and make everything so dark. Okay, so we know it's generally that region. Now moving on to the next equation. Y is greater than or equal to -2x plus 1. So we'll go ahead and plot our y-intercept. And then the slope is -2, which is -2 over 1. So we'll go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, and that will also be a solid line. draw a few more points so we can get a nice straight line. And let's do our shading here. We want all the y values that are greater than the line. So here is basically our line and the y-axis. All the y values greater is this general region. So this general region falls in this area. So we'll go ahead and shade that region. Probably should have used a darker color so we could see the overlap, but that's okay. Now, x is less than or equal to 3. So we see, remember, x, anytime you have a linear equation that only has a variable x, that will make it a vertical line. So we want a vertical line through 3. So that, and we want to include the line, so it'll be solid. So 1, 2, 3. The more points you draw, usually the solution becomes obvious. Now let's go ahead and do the shading here. Let me see, let's choose a color accordingly. Okay, so now we want all the x values that are less than 3. So now this one isn't necessarily above or below, it's basically looking left or right. Well, all the x values to the left are smaller than 3, all the x values to the right are greater than 3, so we obviously want to the left. Now, if we can already kind of see what's happening here, we don't have to make a mess of our shading. We already see that our overlapped region is all of this right here, right? And now we ended up adding this line here, and we want to shade to the left. So all of this was already shaded, overlapped, and now we want everything to the left. So it's going to be this region right here, this little triangle. You guys see that? Okay, so that shaded region, that triangle, is basically our solution. Now we want to find the vertices. So in this case, our vertices seem to be obvious because we did a really good job with the graphing and with our lines are straight. We used nice graph paper. So we can clearly see our vertices. But what if we could not see our vertices? What if we drew our graph or our graph was a little unorganized? What would be the best way? Then you don't want to go by observation because your points may not be intersecting at the correct spot. That's where you want to use the ideas from earlier in chapter 8, where do two lines meet? What are the points they have in common? Basically solving a system. So for instance, I can call this 1, 2, and 3. So I'll just go ahead and do one example of these. Let's see, where do 1 and 2 meet? So for now, we can just forget that they're inequalities and go ahead and keep them as their related equations. And because the y is already isolated in the 2, we can just use a simple substitution method and substitute this expression of y up here. And remember, we're doing equations now. So that would be negative 2x plus 1 is equal to 2x minus 3. I can go ahead and add 2x both sides. That would give me 4x minus 3 on this side equals 1. I can add 3 both sides. I have 4 equals 4x, giving me x equals 1. So we already found x equals 1. Now we have to go back and solve for y. We can go ahead and substitute x into either one of these to find the y value. Remember, we're working with the 1 and 2. So I can substitute into the first one. Y equals 2 times 1 minus 3. Y equals 2 minus 3. Y equals negative 1. So we see that one of our vertices is the point 1, negative 1. And do we see that? 1, negative 1. Yes, we do see that. What are the other two? We can do these two by observation, but this is how you would be able to go ahead and solve if you couldn't quite tell.